So today we're going to be solving in this differential equation using embedded derivatives. So the point of embedded derivatives is looking at terms, preferably like one term over here, and using the derivative of it to solve and relate it to like the other term in some type of way. So we're going to start with this problem. So we know that we could set 2y squared equal to v, let's say, just like a regular substitution. Sorry, actually, we should just make this y squared. And then we're going to solve for the derivative of v with respect to x. So that will just be equal to 2y times dy over dx. So if you see how we're going here, we're using this fact and substituting it back into this. So this is just going to be x times this right side, sorry, this left side is equal to this. So, and then we know that 2y over dy over dx is equal to dv over dx. So what we get is x over dv over dx, x times dv over dx is equal to x squared plus 2y squared, but we said y squared to v, so 2v. So that was basically the embedded part of it. Now it just becomes kind of a regular, we'll say, regular substitution. So we're just going to minus 2v on both sides. We're going to get x dv over dx minus 2v is equal to x squared. And x divided both sides by x, so it becomes dv over dx minus 2 over x times v is equal to 1. So what is this? This is just, we can use now the integrating factor. Correct? Sorry, this should be x, because you do x squared divided by x. Yeah, I don't know why I said that. So now let's solve this with the integrating factor. So we know that p over x is equal to negative 2 over x. So we're going to say e to our u to the x. U of x is our integration, that's negative 2 over x dx, and that's equal to, you could just do this quickly, 1 over x squared. And this just comes with practice in the end. So we're going to multiply this whole thing by 1 over x squared. So we're going to say 1 over x squared dv over dx minus 2 over x to the third v, is equal to, what's this line here? That's equal to 1 over x. So now we can just say that the derivative of our integrating factor, 1 over x squared times v, because all of this is respect to v, dx is equal to, that's equal to 1 over v, so sorry, 1 over x, and that's integral of that. So now this just becomes, these just cancel out, so it just becomes 1 over x squared v is equal to the integral 1 over x is equal to, well, that's equal to ln of x, and remember we have to include the c here. Then we can times by x squared on both sides, so it just becomes x squared over ln of x plus c, it's equal to v, and we know what we set v to originally. We set that to y squared, I believe. What did we set it to? Yeah, y squared, so we're going to say y squared is equal to x squared ln of x plus c, and yeah, you can't really change much from that. And like how we said last video, this ln of x plus c can also be expressed as ln of c of x, so it should be absolute value, just because c can also be expressed as ln of some constant, and you just use natural logarithm rules for the product together. So I'll just write it in both forms. X squared is equal to y squared, and the reason we don't want to square root this is due to, of course, the positive and negative side, so it's going to get confusing, so you can keep, so these are 2 different forms of the solution. Pretty simple compared to other methods, I'll say. So yeah, thank you for watching.